Hello everyone. We're going to take a look at an introduction to Minitab. There we go, an introduction to Minitab, showing you a few things, including making some spreadsheets, calculating descriptive statistics, and doing graphs, which should be helpful for various assignments that we'll look at this semester. So what I'm going to do is go onto our Blackboard page. And in the course info and docs, at the bottom I've added a data set in Minitab for New York colleges. Because Minitab is loaded on this computer, this file will open with no problem. If you're doing this from a home computer, the only way that you'll be able to open a Minitab file like that is to either from the Minitab site download your free 30-day trial, which will take you to the end of the semester, or on that course info and docs page in Blackboard, you can go through the documents there to load a student Minitab version that I think has a license until something like August 31st. If you're using a Mac, or for whatever reason you're having a problem getting Minitab on your computer, you will not be able to open Minitab documents from Blackboard. So that application portal server site, apps.sunybroom.edu, that's what you'll have to go through. Alright, so here's what that's going to kind of look like. Now, from your home computer, it'll be a little bit different because, number one, I'm already on the college system, and number two, I believe somebody on this computer has already kind of accessed and installed that server client. So for me, apps.sunybroom.edu jumps right into all the different software and applications. From a home computer, you're going to see a sign-in screen where it asks for your SUNY Broom username and password. And there might be a little link to click, like I've mentioned on the Getting Started document, that says Use Lite version. I recommend clicking that Use Lite version one because it'll kind of get you there faster, and I think you can avoid actually downloading stuff that way. So what you would do is go into apps.sunybroom.edu, sign yourself in, and then once you're into this screen, you would have to open Internet Explorer, or perhaps Mozilla, either one. What you would do is open that, and now you are on a web browser through the college system. So now you'll notice it's spinning, so it'll take a few minutes. This is a slow computer today. When this web browser actually opens, I'd be able to go to broom.open.suny.edu, sign myself into Blackboard, and then I'd be able to open the Minitab files because you're on Blackboard searching from the college's system, which has Minitab. Right, so this will probably spin for about 5 minutes on this computer. At home, that should only take about a minute to open up. So anyway, that's how you can do this if you're using a Mac. All right, so let me go into that PowerPoint for a second here. The first thing that it talks about is the actual cells and entering data. All right, if you're using just a blank Minitab worksheet for something, it opens with all the cells empty. So for example, for your project, what you'll do is once you collect your data, you'll go and enter the data into a Minitab spreadsheet. Now, Minitab uses just C1 for column 1, C2 for column 2 as the labels. What you should do is give these reasonable names. So, the one example project I had was DVDs, the length of it and the genre. So I might put like minutes as the name of the one variable because I was recording how long the movie was in minutes, and then genre as the other. There are two reasons for this. Well, maybe a handful. One reason, though, is that somebody else that looks at this won't have to guess at what those data values are. You'll have a name that's descriptive. Second reason is just for your own clarity. When you're working in Minitab, instead of seeing C1, C2, C3, you'll see the title you gave the variable, so you'll know which one to check. A third reason is that when you do calculate statistics and make some graphs, Minitab will use minutes and genre and not just C1 and C2 now. And then all I do is type them in, and the first movie maybe is 123 minutes and it was a drama. Next one, 108 minutes and it was a comedy. One thing to be careful of is when you have a variable like genre, notice that Minitab has changed C2 to now be C2-T. The -T there is saying that it recognizes this as a text column, a text variable, meaning you're typing in words instead of numerical values. Any difference will be picked up by Minitab as a separate category. So if I now have another comedy in here that I type in comedy with a lowercase c, Minitab is going to differentiate these two as two different categories. So be very careful on spaces and be very careful on capital letters. Any difference will be picked up as a new category, which you don't want. They have to be identical. One of the notes that I've mentioned in the PowerPoint is that you can copy and paste between Minitab and Word, between Minitab and Excel, and sometimes, depending on what a website is formatted like, sometimes you can copy and paste from a website into Minitab, which is kind of nice. All right, I'm going to get rid of this. One of the nice things about Minitab is that it's quick and easy to use it to calculate the values of statistics. All right, so what I'm going to do is go through the steps here and show you how to do some calculating of statistics using that New York State college data set. All right, so here's my Minitab file. It's got tons of different variables in here. This is a data set that I found online. So notice they had already entered in names of most of the variables here. There's a couple that are missing. C1, well, that's clearly the college name. I'm just going to go ahead and type in college for that one to give that a name. And C2, that's the state, which it doesn't really have to be entered as a variable because I believe they are all New York. Yep. But anyway, that's easy enough to add titles. So let's say that I wanted to do a graph that shows, or not a graph, sorry, let's say I wanted to do a display that shows a bunch of statistics for the math SAT score. So this variable right here that's titled math, that's actually the average math SAT score of students at the college. Notice there's a couple cells with asterisks, like Alfred University has that blank. That means that they didn't have a value to report or data wasn't available, something like that. That's okay. Minitab will just say, okay, there's a missing value there, we won't include it. All right, so if I want the different statistics for the math SAT score, what I'm going to go up to is the stat, basic stats, and display descriptive stats. All right, I'm going to say, hey, the variable I want to do is the math SAT scores. Now notice you could pick all of these at once. You can click, more than one variable if you want to. However many you click, they'll keep putting in there. For this, I'm just going to get rid of those and just go with the math SAT. This one that says by variables, notice it says optional. You don't need to enter anything there. By variable or by variable is a label that Minitab gives when they're asking you, do you want to split this up? And I'll do that in a minute, but for now we'll just keep all of the values for math together. If I click on this little button down here that says statistics, it lets me pick and choose which of these available statistics I want Minitab to display. It's got the biggest ones, the mean, it's got the median, and it's got the standard deviation selected. But there's tons of other options, all right, like variance. So from measures of dispersion, one of the things the book talks about is there's a relationship between standard deviation and variance. If you square the standard deviation, you get the variance, so let's add variance. Interquartile range, that's one of the things in dealing with box plots. We need to calculate the interquartile range in order to find some outliers. We can display a trimmed mean if we want to. A trimmed mean is how they do scores for, like, I believe, diving and gymnastics in the Olympics. They throw out the lowest judge score and the highest judge score and just go with kind of the middle ones. We can remove things if we don't want them. Like they had the SE of mean, that's the standard error of the mean, which we'll talk about that a little bit in chapters 9 and maybe 10, but we can get rid of that. Uncheck anything you don't want. So now if I just click OK to get out of that window and click OK again, up here in what they call the session window is where the descriptive statistics are displayed. All right, so we see the mean math SAT score was 518.27. See the trimmed mean is pretty close to that. Standard deviation was 72.61, and etc. We can read all of those. Let's suppose that somebody asks, well, wait, if we look at the variable type down here, this data set has private colleges and public colleges. Let's see if there's a noticeable difference between these statistics for private schools versus public schools. So if I wanted to do that, I would do basic stats, display descriptive stats. Notice anything that you just entered in is saved. Math is still saved, and the same statistics that I pick are still saved. But what I'm going to do is say, let's split up the math SAT scores by the variable type. So what Minitab's going to do now is basically every private college is going to be treated as the one group, every public college is going to be treated as the separate group, and they will calculate the descriptive statistics separately. So when I click OK, if you look at what's displayed, you see that the variable is still the math SAT score, but it's split up between public and private. So if I look at the two rows there, I can see the N value just tells me how many schools are in the list. There were 55 private schools and 24 public schools. The little N asterisk there that you're seeing, the N asterisks there means the number of observations that were missing. So there were 18 missing observations of math SAT scores from private schools and 4 missing from public schools. Let's see, look at the mean. There's a small difference in the mean. For the private colleges, the mean was about 522, and for public colleges, about 509. That's not a huge difference, though, considering the standard deviations are 73 and 72 respectively. That difference is only a little bit more than 10, which is just a small fraction of one standard deviation. So the means are fairly close. There is a little bit of a higher mean for private. Let's see, if we look at Q1, we got a Q1 of 472 for private versus 462 of public. So again, there's about a 9 or 10 point difference there. Check out the median though. The median is 517 for private and 514.5 for public. So the median is almost identical. There's only about a 2 point difference between the median math SAT score for the two different groups. There's a huge difference for maximum. There was some private school in there that had a student body with a mean math SAT score of 740. Considering perfect is 800, 740 mean math SAT score is ridiculous. So that big outlier on the high side might have a little bit to do with why the mean for the private is about 12 points or so, 13 points above public. But anyway, that's how you split up statistics for a numerical variable by a categorical variable. Now move on to graphing. Graphing tends to be nice. We just go to graphs, the button on top. Most of our graphs, dot plots, histograms, box plots, etc. will be done that way. The only graph that we'll really get into in this class that's sort of the oddball is fitted line plots, which are used for linear regression. That one we went to stat, regression, and fitted line plot. Those steps I believe I put on Blackboard for the Chapter 4 material. Alright, let's take a look at doing some graphs. Okay, so we just did the math SAT score. So let me go up to graph and maybe do a histogram for it. I just want a simple histogram. I want my variable to be the math SAT score. You can play around with the scale and labels and everything like that, but the one nice thing Minitab does is it makes graphs easily edited. All right, now first off, this is a, not perfect bell curve, but it looks like a relatively close to bell curve. The right side is stretched a tiny bit. Right, you can kind of see the peak is right here, this tallest bar. We got 3 intervals to the left of it and 5 intervals to the right. Tiny bit, maybe skewed right, but not much. But one thing I don't really like is the title, Histogram of Math. Well, that's something I want to change. So all I'm going to do is right-click on it. And pretty much you can right-click on almost anything in a graph and say Edit. So if I edit the title, I can now just clear away the title they used, and I can say average math SAT score, which is what this data set actually was. I can change my horizontal axis label here. It says math. I can edit that label, make that score. I like the frequency. That's the correct label for the vertical scale. Sometimes the different graphs have wacky things there, so you can kind of change that as well by right-clicking it. Notice Minitab uses midpoints as the labels for histograms. There's no label for this first class interval. The second class interval is shown with a midpoint of 400. It skips one and then has a midpoint of 500. So that must mean halfway in between 400 and 500 is 450. That must mean this one has a midpoint of 450, this one has a midpoint of 550, etc. You can change how that's displayed too. This probably isn't something you're going to have to do, but if I right-click on the scale and choose Edit the Scale, what I can do is go into binning. Right? Binning means how the class intervals are grouped. Notice they use midpoints, and what we did is made our frequency distributions in graphs based on endpoints, which are called cut points. So we can have this organized however we want. Like maybe we want to say, look, let's make our cut points be these specific values, and what I'll do is just type them in. So I could say, all right, let's make the cut points be, well, let me just start with the 400. What Minitab will do is automatically take my pattern and extend it to the left to cover the data. And maybe I want my classes to be similar to what Minitab did, a class width of 50. So I'll do 400, 450, 500, and then all I have to do is a few of them. Minitab sees I'm counting by 50, so if I say OK, they say we got to extend the bins to cover all the data, so I'll just click OK. Notice what that does to your graph. It gives it a significantly different image. The way that people organize their class intervals will change the way the graphs look, especially for data sets that might be a little bit smaller. And sometimes if you're using class widths that are wide. So it is sort of the same basic shape in that we would look at this and say it's fairly symmetric, maybe a tiny touch skewed right, although this one looks more symmetric than it did with the first assignment of class intervals. Alright, so anyway, that's graphing and editing. Let's do another one though. I'll just get rid of this. Let's suppose I want to do a graph that compares the private versus the public. Alright, so I'll go graph, and one of the nice graphs for comparisons are box plots. So I'm going to go down the box plot. What I have is one y variable, right? The y in this case, the variable is the math SAT scores, but I want to do it with groups. I want to have private and public be the groups. Multiple y's is if you wanted to do something like compare math and verbal, two different columns in Minitab. So I'll leave this one y with groups. My graph variable is the math SAT scores. I want to split that up by type of college. Now Minitab will make the orientation be vertical, and our textbook and the way that I did my notes, I drew them as horizontal. So if I don't like that vertical arrangement, what I can do is choose my box plot. It's with groups. What I can do is click on the scale and just check on the transpose the value in category. That'll just flip-flop where the number line is from being vertical to being horizontal. All right, so one thing that jumps out is, yeah, there is this one asterisk there, right? There's kind of a outlier for private. That's that school that had the mean math score of 740. If you remove that, these box plots look pretty much the same. The minimum value is similar. The first quartile, which would be the start of the box, is similar. The medians are almost identical. There is a little bit of a shift to the right for the private schools Q3. That would mean the third quartile, or the 75th percentile, is a little bit higher for private schools. And the max is definitely larger. So what this is kind of showing me is, if you look at the median and below, the lower 50% of math SAT scores are pretty much the same in public or private schools. But when you look at the highest 50% of the scores, they tend to creep a little bit higher for the private schools. All right, let's do maybe a pie chart. Now, since I have all the raw data entered into columns, I would say use counts of unique values. Have Minitab scan through it and just count up all the similar responses. Values from a table is if you typed in the sums. Instead of typing in all of these raw data, if you just said, okay, private schools 60, public schools 75, that's when you would say chart values from a table. All right, the categorical variable I'm going to do here is type. Let's just do a nice two-category one. Now, there are a bunch of options we can pick down here, like the pie options. I don't really mess around with these. I pretty much just leave those alone. Labels, though, I like to go into, because this lets me put a title on it. So, like, I don't know, title could be, number of public and private schools, or you could just put school type or whatever. But what I like is with the slice labels, tends to be more important when you have maybe 8 different categories as opposed to 2. But I like to have each slice labeled with the category name and the frequency, and might as well toss in percent there. Again, this would be more important for situations with a lot of categories, but let me just click on the draw line from the label to the slice. All right, so what that does is makes my pie chart a lot more readable. If there were, instead of just the 2 categories, if there were 8 or 10, then this key over here would be very difficult, because they're going to have to use like another shade of blue or a shade of purple that's close to that, and without these particular labels right on the slice, it can be hard to distinguish. So this way it kind of makes it very clear that, hey, the blue is the private, the red is the public. And although we could eyeball that as a little bit less than 75% of it blue and a little bit more than 25% red, it's nice to have those values right there. All right, last thing I want to show you, because I don't want to make this too lengthy, is how we could do that linear regression. Right, so if we wanted to do linear regression, would be picking 2 numerical variables to compare. So if we wanted to do something like compare the number of applications received versus the number of students accepted, we could do some least squares regression here. All right, so to do least squares regression, we're not going to go to graph, we're going to go to stat, regression, and fitted line plot. Now it wants to know what my y and what my x variable would be. So what I'm going to say is I think the number of applications received should be the x, because it might stand to reason that the more applications you receive, the higher your enrollment is. So maybe I'll do that. Maybe I'll make x the number of applications received and make y the number that are accepted. All right, so we see that in general there appears to be a positive linear relationship here. This is kind of outside the scope of our class, but it's not good that these values on the low end of the applications received are significantly closer to the regression line than these for the higher number of applications received. But there does appear to be some linear correlation going on. We see this one value, I'm going to point to it, this one data point that's really separated. Right? And if you're in Minitab and you point to something, it'll display what that observation is. This school had 13,703 applications received, but only accepted 1,610 students. So that's why it's so far below the regression line, because it accepted a very small percentage of the applicants. All right, so we get the equation of the least squares regression line up top. You can move it around if you want to, move it down into the graph, although you see that that kind of looks worse than if it's up top. But again, instead of just choosing C1 and C2, Minitab's now using the names of the variables that were there. So the number of applications accepted, the y variable, is equal to 466 plus 0.4683 times the number of applications received. The positive 0.4683, that's the slope of the regression line. That tells you the y value is going up. The number of students accepted is tending to go up by about a half a student for each application, extra application that the college received. Wouldn't be a very good idea to interpret the y-intercept here. Because if we look at our data set, the number of applications received, we don't really have anything that's close to 0. The smallest number of applications received, I think, is in the 300s. So oftentimes the y-intercept does not get interpreted, but the slope always can be. This R-SQ over to the right side there, the 80.9%, that's what our textbook calls the coefficient of determination. And that's why I like doing the fitted line plot. You get a lot of information at once. The scatter plot, the visual regression line, the equation of the regression line, and this coefficient of determination. So I don't want to make the video too long. I think this is enough, but this is kind of Minitab. For your project, you'll be doing some of the same things I just did on this video. So please re-watch it again before you really start work on your project and hand it in. If I right-click on this graph and pick on Copy Graph, I can now paste this into a Word document. So if you're talking and, if you were writing a report and you were talking about the linear regression analysis that you did, this thing would be a great graph to paste directly into your Word document right where you're talking about that. You can put it, right in the middle of the page to break up your text. It's always nicer to insert those graphs within your report than to save them all for the end. If you wanted to put in some descriptive statistics, so I'll just click up here in the session window and go up to where I had those descriptive statistics. Same idea, I can highlight these and copy them and then paste them into a Word document as well. Anyway, thank you for listening, everybody. Hope this helps a little bit as you kind of learn and navigate Minitab a little bit.